Hello everyone. Today let us solve a numerical problem based on relative velocity. You all know about relative velocity. Relative velocity is the velocity of an object with respect to the other object. So the problem goes like this. Two children who are bored while waiting for their flight at the airport decide to race from one end of the 20 meters long moving sidewalk to the other and back. A moving sidewalk is like a flat conveyor belt that people stand on. Jim runs on the sidewalk at 2 meters per second relative to the sidewalk. Peter runs on the floor at 2 meters per second. The sidewalk moves at 1.4 meters per second relative to the floor. Both children make the turn instantly with no loss of speed and return to the starting point. Who wins the race and by how much time? If we observe here, there are two children. One child's name is Jim and the other child's name is Peter. And the flight was delayed, so they were bored at the airport. So they started to race from one end of the 20 meters long moving sidewalk. What is this moving sidewalk? It is just like a flat conveyor belt that people can stand on that. So one boy, he started running on the sidewalk with a speed that is 2 meters per second relative to the sidewalk. Peter runs on the floor at 2 meters per second. One boy, Jim, runs on the sidewalk, that is with 2 meters per second relative velocity with respect to the sidewalk. And the other boy, Peter, runs on the floor at 2 meters per second. The sidewalk moves at 1.5 meters per second relative to the floor. Now, these children, they go from one side to the other side of the sidewalk and they come back. Now, what we have to do? Who wins the race? This is a race. Okay, so let's start. So, let us assume that the starting point is A. Okay, and they go like this up to this point B. That is sidewalk. Its length is what they have given in the problem. Length is, you can see here, 20 meters. So its length is 20 meters. Then one boy, he walks on the sidewalk and other walks on the floor like this. Now, if we observe, the one who walks on the sidewalk, his name is Jim, and the other one who runs on the floor, his name is Peter. Now, let's see while going what happens. While going from A to B, so let us say while going from A to B. Now, Jim's speed with respect to the sidewalk, that is equal to 2 meters per second. That is relative to sidewalk. And the next one, Peter, he goes on the floor, that he runs on the floor. So he runs also with the same speed. You can see in the problem, we can see Jim runs on the sidewalk with 2 meters per second. Peter runs on the floor with the same speed, that is 2 meters per second. So both of them have the same thing which they have given in the problem, that is 2 meters per second. Now sidewalk, it also moves with a speed of 1.5 meters per second relative to the floor. It's a simple problem, nothing is difficult. Only thing is we have to understand the problem. Now, while going Peter's time. Let us take Peter's time to finish. Peter's time to finish. This is only for going. Peter's time to finish, that is 20 meters. And we know that. Let us take it as T1, that is 20 divided by 2, because we know, all of you know, velocity is equal to distance upon time. Therefore, time is equal to distance upon velocity. So, it is 20 divided by 2, which is 10 seconds. Then, the one which goes on the sidewalk, he is going with a relative velocity of 2 meters per second. Therefore, Jim's time to go, that is, because it is relative velocity with respect to the sidewalk, it is relative velocity. So, his time, to calculate his time, we have to take the velocity of Jim is equal to 2 plus 1.5, because he is moving along the sidewalk, and sidewalk is also moving with 1.5 meters per second. So 2 plus 1.5, which is 3 meters per second. Therefore, his time, that is Jim's time, let us take as T2, that is equal to 20 divided by 3.5, that comes around 5.71 seconds, because it is a relative velocity. This is the point you have to note. Relative velocity, that is Jim's velocity is 2 and sidewalk has a velocity of 1.5. Therefore, both are moving in the same direction. It is 2 plus 1.5. Therefore, it is 3.5. Substituting this 3.5 in this equation, T is equal to D divided by V, that is distance is 20 and 3.5 is his speed, then total, that is velocity, is 3.5 meters per second. Then let us see, while coming back, let us take it is return trip. While coming back. Now this is from B to A. B to A. Now what happens here? Let us observe. Now what happens now? Once again, let us consider. Peter is walking, Peter is running on this platform. So where is Peter now? He is not on the sidewalk. Peter runs on the floor just next to the sidewalk. So he has the same speed. So Peter's speed, let us take T1, Peter's time, let us take as T1 dash. It is same, that is 20 and divided by 2, which is 10 seconds again, because he comes back with the same speed, and when they take the turn also there is no loss of speed. That's what they told in the beginning of the problem. Now let's see about Jim. Jim, while coming back, he is moving now opposite to the movement of the sidewalk. Suppose if the sidewalk is moving like this, now Jim is walking opposite to the sidewalk. Therefore, his relative velocity with respect to the sidewalk, now it was 2. Now with respect to sidewalk, what is the resultant velocity? That is Jim's relative velocity. It is, earlier it was 2. Now it is 2 and sidewalk is moving in the opposite direction. This is sidewalk is moving in this direction, but Jim is moving in the opposite direction. Therefore, 2 minus 1.5. Earlier here we have done 2 plus 1.5, but now here we do 2 minus 1.5, which is 0.5 meters per second. Then what happens now? And the next thing is time for Jim. Time for Jim's return. That is T2 dash, let us think. T2 dash is equal to, that is distance upon velocity, that comes around 40 seconds. Now we have the total time for both of them. You can see here Jim's time and Peter's time we have already calculated when they were going. Now this is Peter's time to go from one side to the other side, and this is Jim's time to go from one side to the other side. Then after that, here we got Peter's time. You can see Peter's time to go from one side to the other side. This is the same thing, 10 seconds. But for Jim, it is 40 seconds. Okay, I just clear this color. I'll take some other color. This is 40 seconds. Now adding both of them, then Peter's total time. That is T1 plus T1 dash. So how much is T1? To 10 seconds, and here again it is 10 seconds. So that comes around, which is 10 plus 10, which is 20 seconds. Jim's total time. Let's go. We can see here Jim's, if in the red color it is given 5.71. 5.71. Therefore, what is his total time? His total time is 5.71 and 40. That is, his total time is T2 plus T2 dash. And how much it is? Here red color 5.71, and here in this yellow color 40 seconds. Therefore, total time is 5.71 plus 40, which is 45.71 seconds. Now we got both for Jim as well as for Peter. Now these are the things. For Peter it took 20 seconds to go and come back. For Jim it took 45 seconds, that is 45.71 seconds to go and come back. Now who came first? Peter came first. So who wins the race? Peter wins the race. By how much time? 45.71 minus 20, that is 25.71 seconds. So finally, who wins the race? That is what they have asked in the question. Finally, who wins? Peter wins the race. By how much time? He wins the race with a difference of 45.71 minus 20, that is 25.71 seconds. So he wins the race with a time difference of 25.71 seconds. This is the answer. Please go through that, and we will meet in the next video with another numerical problem. God bless you all.